You rest for a moment, letting the room dim around you. Some nights the sky feels older than memory itself, as if its silence is holding a secret too delicate to speak aloud. And tonight something in that silence seems to be waiting for you. Your breath softens, thoughts fall into slower shapes. The world loosens its grip just enough for wonder to slip through. Far beyond the roofs and the sleeping streets, a small interstellar wanderer moves across the dark. Cold, unhurried, carrying the dust of places no sun has ever touched. For a long time, it drifted quietly, a tired traveler, gliding through the solar wind like a forgotten note, until the moment the quiet broke. Not with a boom, not with violence, just a thin, impossible shift, a soft fracture that reshaped everything around it. If you close your eyes, you can almost imagine that faint moment, ancient ice giving way, a whisper of light escaping from a shell that had held it for billions of years. Before we follow that quiet turning point, if these gentle night journeys bring you comfort, you can support the Light and Thought channel in the softest way, like a subscribe or a small message telling me where in the night you're listening from. Only if it feels right. Now, breathe once more. Let the night settle around you like a warm, slow tide. Because something fragile has shifted out there in the dark, and its story is opening quietly right here beside you. The quiet settles around you as if the room itself is listening. And somewhere in that stillness, your attention rises like a slow tide toward the sky, toward a place where something small, cold, and impossibly far has begun to behave like nothing you've ever known. You don't see it with your eyes, not yet. But you feel the pull of it, the sense that a story is unfolding far above you, written in a language made of faint light and ancient dust. For most of its life, 3IATLAS was just a wanderer moving through the interstellar dark. A piece of frozen material, older than your sun, shaped by temperatures so low, they barely belong to the world you know. It drifted for millions of years, untouched, unbothered, carrying memories from systems that no longer exist. Scientists say its path is proof of this. Its motion is hyperbolic, too fast and too open to be trapped by the gravity of any single star. An object only moves like that when it comes from the outside, when it has been wandering long before human beings learned to look up and wonder. You imagine it, a small silhouette, gliding through the void, moving at about 30 kilometers every second, not rushing, not fighting anything, just following momentum, born somewhere beyond the reach of sunlight. And yet, you're here now, lying in the quiet, drawn toward it. There's something about its story that feels strangely familiar, as if even across light years, a fragment of the universe can whisper to you, not through sound, but through the calm certainty of physics. For weeks after astronomers first spotted it, 3IATLAS behaved like a typical interstellar object, a dim point reflecting sunlight that barely reached it, its surface cold enough that even the hardest rocks behaved like glass, its brightness steady, its motion, predictable charts and calculations lining up neatly like beads on a string. But then something changed. At first, the shift was so subtle that no one noticed. A tiny fluctuation in brightness, 1% maybe less, as if the light touching its surface flickered for a heartbeat. You've felt that before, haven't you? Those moments when something in your life is about to shift, but the world around you stays strangely normal. A silence that isn't just silence, a stillness that holds its breath. Astronomers call this kind of change a light curve anomaly, a whisper in the data that tells them something beneath the surface is moving, adjusting, struggling, becoming. But to you lying here in the dimness, it feels like the first ripple of a deeper story, the kind of moment you don't understand until much later. The anomaly grew slowly, a soft pulse in the numbers measuring how much sunlight the object reflected. Nothing dramatic, nothing you could show to someone and say, look, the universe is shifting, just a small change that didn't belong. And yet, Small changes matter, especially when they happen to something that has been unchanged for millions of years. You picture it now, the sunlight hitting its fractured surface, the icy grains shimmering in ways they shouldn't, the reflection wobbling like the breath of someone trying not to cry. Scientists who studied its brightness noticed another detail. The object didn't seem to spin steadily. Instead, it wobbled ever so slightly, a motion called precession, a sign that the interior might not be uniform. Maybe hollow in places. Maybe layered with different densities of ancient ice. No one could be sure. That's the thing about objects like 3IATLAS, they carry more questions than answers. And yet, the questions are what make the sky beautiful at night. As you sink deeper into the quiet, you imagine yourself holding that object for a moment, feeling how fragile it is, how easily its surface could crack under forces too small to see. Light curve patterns hinted at something inside, loosening a tension building beneath its shell. Not enough to break it yet, but enough to bend the way the light touched it, like a whisper brushing past your ear. You breathe slowly, feeling your chest rise and fall, and the rhythm sinks with the faint pulse of numbers astronomers recorded night after night. One of them mentioned in a report that its brightness varies like a heartbeat that doesn't know if it should speed up or slow down. You like that sentence. There's something soft in it, something honest. It makes you wonder if you could stand beside the object in space, floating next to that ancient wanderer. Would you hear anything? Would the ice groan? Would the dust shift? Would you feel the vibration of change long before the break came? Maybe. Or maybe the silence would be so complete that the only sound you noticed was your own breathing, echoing in a place where breathing doesn't belong. The truth is simple. Even before the fracture, 3IATLAS was already rewriting its own path. Once an object starts changing its brightness in ways that don't match its rotation, it means sunlight is revealing something hidden. Grooves on the surface, micro cracks forming in the ice shadows, moving differently across each rotation. In astronomy, shadows often speak louder than light, and the shadows around 3IATLAS were beginning to say something faint but undeniable. This quiet traveler was entering a new chapter of its existence, a chapter shaped by forces it carried within itself, pressures locked for billions of years, stresses absorbed from supernova shockwaves long ago, memories frozen into its structure, like old stories etched into brittle skin. You let that thought settle, because every object, no matter how distant, is shaped by what it has survived. Sometimes you wonder if the same is true for you, if the things you've moved through the pressures you didn't choose, the moments that bent you quietly from the inside, have shaped your path, the way ancient shock waves shaped 3IATLAS. Maybe that's why this story feels so close. Because even in the dark, something small and quiet can continue moving until the moment it decides to change. The sky didn't announce what was coming. The object didn't warn anyone. There was no flare of light, no burst of gas, no tail streaming behind it. Just a subtle shift in reflection, as if the universe was clearing its throat before whispering something you weren't supposed to miss. As weeks passed, astronomers noticed one more thing. Its trajectory, though predictably interstellar, carried a tiny deviation so small it wasn't immediately obvious. A deviation that hinted at internal processes adjusting the object's spin and balance. A nudge against the equations that made scientists pause, then stare, then stay awake longer than they planned. You can almost imagine them: cold coffee, tired eyes, telescopes humming in the background, looking at the same faint dot again and again, because something about it felt different. Maybe you know that feeling too, when you can't explain why something matters, only that it does. Tonight, lying here in the hush of your room, you feel it again. That pull, that quiet gravity of curiosity. And somewhere in the dark, far beyond the moon, beyond the planets, beyond the warm breath of the solar wind, 3IATLAS drifts on, carrying the growing tension inside it, toward the moment when the silence will finally break. You breathe once deeply, and the story moves with you gently, quietly, the way distant things always do, before they reveal the truth waiting inside them. The night holds you a little closer, as if it senses that you're ready to drift deeper into the quiet place, where science becomes something soft enough to dream with, out there, far beyond the warmth of Earth. Atlas continues its silent glide, a faint speck of wandering ice that refuses to behave the way the universe taught objects like it to behave. For most of its journey through the solar system, it moved with a calm predictability that comforted the astronomers watching it. They plotted its position each night, tracing the elegant curve of a hyperbolic path that confirmed what they already suspected. This was not a child of the sun, but a visitor from somewhere beyond. Sometimes you lie here and wonder what that path must have felt like from the inside, millions of years sliding through a darkness so absolute that even light forgets how to travel. It wasn't always alone. Objects like 3IATLAS rarely are. They're born in crowded nurseries of dust and ice, orbiting stars much older than yours. They survive the collapse of those stars, the shock waves, the radiation, the exodus. Maybe you understand that feeling, being shaped by forces you never saw coming, and leaving places you didn't know how to stay in. As sunlight began to touch its surface for the first time in millions of years, an Atlas woke up slowly. The energy warmed its outer shell, causing ancient ice to shift molecules to vibrate in ways they hadn't since long before Earth existed. Scientists suggest that objects like this carry layered structures, formed under conditions colder than anything on your planet. Temperatures so low that the word frozen isn't enough heat, becomes a rumor movement, becomes memory. When that kind of material meets sunlight again, even gently, it changes. You picture the warmth seeping into it, microscopic pockets of trapped gas, stirring old fractures, tightening or loosening crumbs of dust beginning to release tiny glimmers of refracted light. It's strange how something so small can carry so many stories inside it. For weeks, its brightness rose and fell in patterns that looked almost like breathing. A slow inhale of light, a softer exhale. But no one expected what would come next. Not yet. For now, the object seemed merely curious, as if shaking off the cold of interstellar sleep, testing how much of the sun's warmth it could hold without changing too quickly. There was one detail, though, something scientists noticed in the early data, a gentle asymmetry in the way the light spread across its surface. It wasn't rotating evenly. Most interstellar visitors spin like tops, predictable, steady, mathematical. But 3IATLAS turned slower on one side, faster on another, as though one hemisphere was denser or carried a scar from an old cosmic impact. You imagine standing on its surface, feeling the uneven tug of motion beneath your feet, listening to the faint crackling of ice adjusting to sunlight after ages spent in the dark. The uneven rotation suggested something more, that the object might not be solid all the way through. Maybe it held voids inside it, hollows carved by time and cosmic trauma. Maybe its interior was layered like pages in a book, written by different stars. No one could know for sure. All they had was a flicker of reflected sunlight and the stubborn instinct that this object had more to say than its small size suggested. Some nights astronomers described it as restless, not in a poetic way, but in the way numbers behave when something beneath the surface is preparing to shift. And you feel that word linger in your mind, restless, because there are times when you feel that too, when a stillness inside you begins to twist gently, quietly, warning you that a turning point is near. The more the sunlight touched it, the more 3IATLAS revealed itself. Its reflectance spectrum, the fingerprint of its materials, showed hints of sodium iron and frozen carbon monoxide, exactly the kinds of elements expected in interstellar ice. But the ratios were unusual. Not wrong, just older. Older than Earth. Older than your sun. Older than most of the stars you can see. It's strange to think of age in terms of elements, but in astronomy age is measured by the dust a thing has carried through time. The spectrum also had faint signatures that suggested the object once passed through the shock wave of a supernova, the kind of violent event that shatters solar systems and sends fragments spiraling into interstellar exile. You wonder what that moment must have been like, being thrown across the galaxy by a dying star's final breath. The sunlight that touched it now was softer, gentler, almost tender in comparison. And yet, even in this quiet phase of its journey, 3IATLAS was changing faster than it should. Its trajectory, though still unmistakably interstellar, showed a deviation so small it would have been meaningless if it hadn't accumulated night after night. 1/1000th of a degree, maybe less. But that's the thing about space. Tiny shifts become enormous distances with time. You think about your own life, how the smallest decisions, the softest thoughts, the quietest realizations can eventually move you across the entire map of yourself. Maybe that's why the astronomers kept watching so closely, because they knew that the story of an object is written not in its brightest moments, but in the almost imperceptible changes that come before everything breaks open. You imagine the scientists sitting at their screens, tracing the faint line of motion, watching for signs that the object was preparing for something more. Not in a dramatic way, not in a cinematic flash, but in the subtle way nature always works, one soft shift at a time. The sunlight glinted off it again, just slightly differently than before. A wobble, a shimmer, a pulse of reflection that suggested internal stresses building like distant thunder. If you were holding it in your hands, cold, fragile, ancient, you might have felt the faintest tension in its layers. Not enough to be dangerous, just enough to notice. You take a slow breath, letting the thought settle through you like a drifting fragment of starlight. There is a point no one can see, a point in any journey where the buildup becomes too much to stay the same. 3IATLAS was approaching that point, not with noise, not with spectacle, but with the quiet inevitability of something preparing to shift from one truth into another. And in the stillness of your room, you feel that moment drawing nearer, gently, softly, as though the universe is exhaling right beside you. The sky above you feels quieter tonight, as if every star has paused its breathing to listen for something delicate happening far beyond their reach. You lie still, letting that quiet settle through you, letting it fill the spaces between your thoughts, the way starlight fills the darkness between galaxies. Out there, 3IATLAS continues drifting, steady, pale, unassuming, yet carrying inside it a tension that has begun to shape the way light wraps around it. Most objects in the solar system behave predictably. They spin, reflect, dim, brighten, following patterns so steady you could mistake them for the heartbeat of nature itself. But not this one, not tonight. Its brightness curve, the rhythm of the light it casts back toward Earth, has softened into a strange, uneven pulse. Long, slow rises, abrupt, hesitant dips. Moments where the reflection seems to tremble, as though uncertain of its own shape. Scientists describe this state as pre-fracture instability, a sign that the internal structure is beginning to react to changes in temperature and rotational stress. You don't need the terminology to understand it. You've felt that kind of moment before, when something inside you begins to shift, long before the world outside notices. The warmth of the sun keeps brushing against its frozen layers, melting molecules one by one, introducing tiny fractures that crawl through the surface like lines of quiet thought. As the ice rearranges itself, the object's rotation develops a subtle unevenness, a millisecond faster, a millisecond slower, small enough that most observers wouldn't notice, yet profound enough that the entire object begins to move as though carrying a memory too heavy to bear. You imagine being that fragment of ancient ice, feeling sunlight again, after a lifetime of darkness, the warmth sinking deeper than it ever has, searching for weak points, finding them, whispering to them. Some research teams mentioned that the variations in brightness resembled the flicker of a candle in a room without wind, steady at first, then wavering for reasons no one can see. You've watched candles behave that way. You know the feeling when a flame dances, not because of what surrounds it, but because of something within. The astronomers tracking 3IATLAS also noticed that the object's orientation shifted slightly each night, as though trying to settle into a new equilibrium that it couldn't quite reach. Objects in space don't try to do anything, but the human mind can't help but imagine intent in motions that look like hesitation. There is something deeply emotional about watching a piece of the universe struggle to remain whole. As the object approached the region of space where solar radiation is strongest, its temperature rose by fractions of a degree, numbers so small they would mean nothing to you, but everything to something made of fragile ice and dust. Even those tiny temperature changes were enough to alter the stability of its outer layers. Some areas expanded, others shrank. Stress lines formed along old boundaries that had been dormant for billions of years. If you could touch its surface, you might feel those lines like the fine cracks in a piece of old porcelain. Not dangerous yet, but ready to deepen. You breathe softly, imagining the object turning slowly in the cold sunlight, carrying this quiet tension the way you once carried unspoken thoughts. Just before the fracture telescopes recorded one more anomaly, a sudden but gentle dimming, a drop in brightness that lasted only seconds. Not a collapse, not a flare, just a moment where the object seemed to pull its light inward as though gathering itself. Scientists suggested that the dimming was caused by an abrupt change in orientation, a small shift that revealed a darker side of the surface to the telescopes watching it. But you sense something else in that image, the feeling of a long exhale, the pause that comes just before something finally gives way. The dimming was followed by silence in the data. Not literal silence, just a stretch of time where the numbers stopped changing. Brightness flat, rotation steady, trajectory calm, stillness pretending to be normalcy. It reminds you of those moments in life when everything goes still. In the seconds before a decision is made, before a truth emerges, before a version of yourself finally cracks open. The room around you feels as if it understands, as if the quiet here is echoing the quiet out there. Astronomers later said that if you look at the graphs closely enough, you can see the entire story leading up to the break, the restless light, the subtle shifts, the tremors hidden in the data. But at the time, no one knew, because the universe doesn't announce the moments that matter most. It lets them unfold softly, like sleep. You picture the object floating in the emptiness, holding its breath, the way you sometimes do when you're trying to stay composed. There is a beauty in that state, the almost unbearable quiet before a transformation. Another faint shift appeared so small, it could have been noise, a tiny increase in brightness, like the flicker of a star hidden behind a cloud of dust. For a brief moment, the object looked almost alive, its shimmer rising in a way that felt more like reaction than reflection. You wonder what it would have felt like to stand near it then, to watch the surface tighten under the pressure of ancient forces, to witness billions of years of history curl toward their breaking point. The subtle increase in brightness was the last sign, the final whisper, before silence returned once more. And this silence was different. It wasn't the stillness of a wandering object moving through the solar system. It wasn't the quiet of deep space or the peace of a frozen body untouched by warmth. It was the kind of silence that happens only when something is about to change, in a way no one can undo. You feel it now settling through your chest, dark and soft and full of anticipation. A fragile object carrying the weight of stars. A tension older than the earth. A moment balanced between holding on and letting go. The last breath before the break. You close your eyes and let yourself drift into that moment. A moment suspended in the vastness of space, waiting for the universe to shift just a little more. And somewhere in the distance, 3IATLAS waits with you, holding its silence until the time finally comes for everything to change. Something in the night shifts around you so gently you almost don't notice it. A slight tightening of the quiet, a soft inhale from the dark, as though the universe itself is preparing for a sound you will never quite hear. You lie there, letting the silence unfold, letting it stretch out in front of you, the way the space between stars stretches across eternity. And somewhere in that distance, 3IATLAS hovers on the edge of a moment that has been building for millions of years. There are events in nature that arrive with thunder, with fire, with violent declarations. This is not one of them. When the fracture comes, it does not announce itself with a burst of light or an explosion of dust. There is no shockwave, no flare, no sign that would catch the eye of someone casually looking up at the sky. The break begins in silence. At 3IATLAS's surface, the sunlight triggers the final rearrangement of its ancient ice. Temperatures rise by fractions of a degree, numbers too small to matter on Earth, but enormous to something that has slept in darkness for so long. Molecules shift. A thin seam deep inside the object tightens, then relaxes, as though deciding which way to breathe. Then in a fraction of a second that instruments almost miss entirely, the structure gives way. It's not a shatter, not even a crack in the way you imagine cracks sounding. It's more like an exhale, a tiny release of tension that has been held for countless ages, a quiet surrender of forces that finally choose to let go. Telescopes on Earth catch it not through sound, not through vibration, but through a flicker in the light. A sudden spike in brightness, followed by a brief dip so subtle, the data looks almost like a heartbeat skipping. You picture the object turning in the sunlight, its surface trembling with the smallest of shifts. And then almost gracefully it separates. Two pieces where there had been one. The larger fragment, still carrying most of the mass, drifts forward on the same interstellar trajectory, its motion steady, its brightness stabilizing. But the smaller piece, that one behaves differently. Instead of dimming, instead of shrinking into the shadows, as small fragments usually do, it brightens. Just slightly at first, a glow so faint you'd think your eyes invented it. Then more and more, until the smaller piece shines with a clarity that no one expected. Scientists will later note that the freshly exposed interior reflects sunlight more efficiently, that the smoothness of the new surface scatters light in a way the telescope interprets as brightness. But standing here in the quiet of your room, listening to the drifting hush of your own breath, you sense something different in that glow, not drama, not spectacle, just the soft truth that sometimes the deepest light comes from places that finally break open. The two fragments separate slowly, as though reluctant to leave each other. No violence, no recoil, just a gentle widening of the space between them. It makes you think of people, how partings don't always arrive with shouts or final words. Sometimes they happen in silence, in a soft shift of direction, in a quiet loosening that reveals what was fragile all along. Astronomers analyzing the data notice the change almost immediately, not because the object looks broken, but because the light no longer behaves the way a single body should. The brightness curve splits in two rhythms where there should be one, two identities emerging from a single past. The larger fragment rotates predictably, the smaller fragment spins faster, a sign that angular momentum was redistributed during the break. You imagine the moment of separation, as two dancers moving apart, each carrying the motion that once belonged to both. The small fragment's rapid spin exposes new surfaces to sunlight in quick flashes, glints of brightness that make it appear almost alive. Some telescopes report a faint haze around the new piece, a whisper of dust released as the surface split open. But the dust fades quickly, absorbed by the solar wind and carried away like breath on cold air. The scientists studying the event describe the fracture as unexpected, unmodeled, inconsistent with typical cometary behavior. You can feel what they mean. Nothing about the moment feels typical. Nothing feels ordinary. It feels intimate, like witnessing a transformation that wasn't meant for human eyes. The smaller fragment glows brighter than the parent body did before the break, a phenomenon so rare it becomes the focus of every research note written in the days that follow. Some compare it to fresh ice exposed beneath the shell ice that reflects sunlight with a purity untouched by cosmic radiation. Others think the Inner layers contain materials that respond differently to heat materials, shaped in environments that no longer exist. But one detail stands out above all the others. The smaller fragment drifts forward with a slightly altered path. Not wildly, not chaotically, just enough to tell astronomers that the break was internal, not caused by a collision or an external force. A transformation from within. You breathe slowly, letting the idea settle. Some things break because they must, because the pressure inside becomes heavier than the forces holding them together. The sky outside holds no blame for it. The sun did not push too hard. Gravity did not strain it. No passing body struck it. The change came from inside the ice itself, from the ancient tension that had survived longer than any star in your night sky. You wonder how many things in your life have changed the same way, not because something hit you, but because something within you finally shifted. As the two fragments drift apart, sunlight catches on the smaller piece, with a kind of softness that reminds you of a candle in a dark room. Astronomers record it. They compare brightness curves. They run calculations. They debate models that don't quite make sense anymore. But for you lying in the gentle quiet of your night, the numbers don't matter. What matters is the shape of the moment, a moment when something ancient chose to reveal a new side of itself, even if only through a fracture. The silence after the break is deeper than the silence before it. A quieter quiet, a softer stillness. A sense that the universe has just told you a secret so old it barely remembers the words. You breathe in slowly, letting that secret settle inside you like drifting stardust. And somewhere far beyond Earth, the two fragments of 3IATLAS move on, each carrying a part of the story that once belonged to a single fragile whole. The smaller one turning softly bright enough now to leave a whisper of light on the edge of your thoughts. The larger one steady silent, almost relieved. The sky doesn't rush their parting. It simply watches patient, the way it has watched every transformation since time began. And you watch with it held gently by the dark, listening for the next quiet truth that waits in the space between stars. The night around you feels softer now, as though the darkness itself has leaned in, listening more closely than before. You lie still, letting that quiet deepen, letting it settle in your chest like the gentle weight of a warm blanket. Out there in the cold expanse, the two fragments of 3IATLAS continue drifting apart, slow, unhurried, guided only by momentum, older than memory. The smaller fragment shines with a new kind of light. It isn't brighter because it wants to be, or because anything dramatic has happened to its surface. It shines because something inside it has finally been revealed, materials that haven't touched sunlight in millions, maybe billions of years. Astronomers noticed it first in the spectra, a thin line, barely a rise in the graph, a whisper of color where there hadn't been one before. Spectral data is one of the quietest languages in science. Nothing shouts, nothing declares. It just hums in faint lines of brightness, telling stories through small shifts in wavelength. And this new line, this fragile, unexpected hint of something, was enough to make even tired researchers sit up a little straighter. The freshly exposed interior of the smaller fragment reflected sunlight differently from the older radiation-worn surface. Where once the spectra had been muted, softened by cosmic dust and interstellar erosion, the new surfaces gleamed with sharper signatures. Sodium, once faint, rose in clearer peaks. Iron lines sharpened. Carbon monoxide emitted a frozen echo of the temperatures it had known long ago, back when the object was still part of a distant system. But it wasn't just the familiar elements. There were traces, whispers, barely measurable, of compounds that suggested the ice inside had been shaped under a pressure more intense than anything common in your solar system. Scientists proposed that the object might have formed near the shock front of a massive star explosion, a supernova that scattered heavy elements like seeds across the void. You imagine it now, the fragment once embedded in a nursery of fire, bathed in radiation, strong enough to alter the chemistry of its layers, yet not strong enough to destroy it. Survival is its own form of memory. When the surface broke open, this ancient memory shone out like light passing through stained glass that had been hidden behind dust for ages. The telescopes recorded a slight increase in albedo, the measure of reflectivity, and a subtle shift in the balance of spectral colors. But numbers alone don't convey the feeling of it. For you, lying here in the calm darkness, it feels more like listening to a whispered confession from something too old to remember what silence is supposed to sound like. The smaller fragment rotates faster now, its fresh surfaces catching sunlight in brief flashes that reveal a chemistry untouched by time. Every rotation brings a new glint, a new spark, a fleeting shimmer that hints at the materials buried deep inside. Some of those materials may be older than the Milky Way itself. Pre-solar grains, tiny particles formed in the atmosphere of dying stars, sometimes embed themselves in objects wandering between systems. If 3IATLAS carries them, then the light leaving its surface now is carrying whispers from before the sun was born. You breathe gently, letting that thought expand inside you. The idea that something so small could hold a story so vast reminds you of how much can be hidden beneath the surface of a person too. The larger fragment, still intact, shows no such spectral surprises. Its surface is older, weathered by cosmic rays, less willing to reveal anything new. But the smaller fragment keeps turning, keeps shining, keeps offering clues to a chemistry shaped by galaxies, not by planets. When the first reports of the new spectra came in, some scientists didn't believe them. They thought the readings were noise artifacts from the instrument, a trick of the angle. But the lines repeated night after night: sodium bright, iron steady, carbon monoxide crisp, a faint cyan glow barely there, but undeniable, suggesting the presence of ionized molecules reacting to sunlight for the first time in a cosmic age. You imagine watching that glow in person. It wouldn't be bright. Not a halo, not a beam. Just a thin, delicate blush of blue-white shimmer hugging the fragment's surface, like breath condensing on cold glass. You could miss it if you looked away for a single heartbeat. Small truths often arrive like that, soft, fleeting, almost shy. Astronomers described the new spectra as unexpected clarity, a phrase you like. There is something gentle about clarity that arrives unexpectedly. It reminds you of times when you realized something about your own life, not through a dramatic moment, but through a quiet shift in how the light hit the truth. The smaller fragment's composition also suggests something else, that the pressure inside it must have been uneven for a very long time, for its inner layers to differ so much from its outer shell. Pressure leaves signatures, tiny distortions in crystal structures, microscopic alignments of ice molecules. And those signatures can survive billions of years, like scratches on ancient stone. You think about how pressure shapes people too, not always with noise, sometimes with stillness. The object's spectra show that its inner chemistry holds more volatile compounds than the outer shell. Compounds that should have evaporated millions of years ago if they had been exposed to sunlight, which means the interior must have remained sealed until the fracture. A sealed memory opened by a moment of quiet breaking. There is something strangely comforting in the idea that only after the object broke could it reveal what it had carried for so long. Maybe the universe is not always asking you to stay whole. Maybe sometimes it's asking you to open. As the fragment continues to drift, sunlight keeps painting its surface with a growing palette of colors that the spectra capture in patient lines and curves. You picture the scientists watching it, tired eyes, quiet rooms, screens glowing in the dark, seeing not just data, but a story unfolding in wavelengths barely wide enough to hold a breath. And you see yourself here resting in the gentle dark, listening to the story, the way you'd listen to a soft voice telling you something true without trying to make you understand too quickly. The light from 3IATLAS has traveled millions of kilometers to reach Earth. But the truth it carries has traveled far longer through star nurseries, through explosions, through the cold silence between suns. Tonight that truth reaches you quietly, folding itself into your thoughts like a secret you were always meant to hear. And the fragment, still turning, still shimmering, continues whispering through its spectra, revealing pieces of a chemistry that has never belonged to this place yet somehow belongs to you tonight. The night has a way of holding you gently when you drift far enough into quiet. And tonight, as you lie still in the soft darkness of your room, you can feel the silence deepen around you, as though the air itself has leaned closer to hear what happens next. Far beyond Earth, the smaller fragment of 3IATLAS turns slowly, its fresh surface catching sunlight in a way that feels almost tender. The glints are faint, brief, delicate, yet each one carries a chemistry so old that the universe itself seems to pause for a moment to remember. New spectra keep arriving at the observatories on Earth. Each night brings new peaks, new whispers of elements that have waited in darkness longer than your planet has existed. And the more they study those lines, the clearer it becomes that the chemistry inside this fragment should not be possible in a world shaped by the laws you know. You imagine holding the fragment in your hands, feeling its coldness sink into your skin, feeling how fragile it is despite the age carved into its layers. And somewhere beneath that smooth, icy shell lies a structure shaped not by a single star, but by the breaths of many. Scientists examining the spectra see hints of crystalline ice that forms only under extreme compression pressures, far beyond what comets or asteroids experience in your solar system. These ice structures aren't the soft, familiar frost you've seen on winter windows. They're denser, tighter, like the grain of a gemstone that took ages to settle into place. Some astronomers believe the fragment may have been forged in the gravitational crush of a collapsing molecular cloud, a place where dust and gas press together so tightly that even atoms grow quiet under the weight. Others suggest the ice might be relics from the boundary of a supernova shockwave, a region where heat and pressure rise in violent waves, then cool into new structures that shouldn't exist anywhere else. Pressure in its quiet way creates things that defy expectation. You know that feeling too, don't you? How certain moments in life press you into shapes you didn't expect. Shapes that reveal something you didn't know you could hold. The scientists also notice unusual amounts of trapped volatiles gases like carbon monoxide and nitrogen that should have escaped long ago if the object had ever been warmed before. But these gases are still here, still sealed in the crystal lattice of the ice, like secrets held too tightly. This means only one thing. The interior of the fragment has been locked in darkness since the earliest days of its existence. It has never thawed, never melted, never broken until the moment you witnessed in the quiet of the night. The chemistry of its surface and the chemistry exposed by the fracture are nearly opposites, as though the fragment carries two different lifetimes inside it. The outer layers tell a story of endurance, millions of years exposed to cosmic rays so powerful they reshape molecules one particle at a time. These rays darken surfaces, break bonds, erode soft structures, until all that remains is a thin, brittle shell that remembers every collision it has ever survived. But inside, beneath that ancient crust, the chemistry is gentle, volatile, soft, untouched, like breath trapped under glass. You lie there for a moment, letting that contrast sink in harshness outside, fragility within. It feels familiar, it feels human. The freshly exposed material also reflects sunlight with a purity almost never seen in interstellar objects. Newly revealed ice is like a newborn mirror, sharp, bright, unburdened by the scars of cosmic radiation. The increased albedo is one of the first clues that the chemistry inside this fragment is something rare. But albedo isn't the only surprise. As researchers examine the thermal data, they notice something else. The temperature of the fresh surface rises and falls more rapidly than expected. This suggests that the material inside conducts heat differently from typical cometary ice. Maybe its structure is layered. Maybe it contains microcrystals formed under high-pressure cooling, far from any stable sun. You picture the fragment turning its surface, warming in moments, cooling, in moments breathing light, and releasing it with a rhythm so delicate only the instruments notice. Some believe the chemistry inside contains isotopes that formed around dying stars, rare versions of common elements that behave differently when struck by sunlight. Other astronomers argue that the fragment's strange chemistry might be evidence of interstellar mixing when dust from multiple stars merges into a single object over millions of years, creating a mosaic of stellar histories in one fragile piece of ice. A patchwork of origins, a quiet archive of places it once passed through. You think about how people too become mosaics of the places they've been and the experiences that settled inside them. No single event defines you. No single star defines 3IATLAS. Another mystery rises from the spectral data, a faint emission line that doesn't correspond neatly to any known substance. Not strong enough to name confidently, not weak enough to ignore. Some researchers call it an artifact, but others think it might be the signature of complex organics, simple building blocks of life that sometimes form in the cold chemistry of interstellar ices. There is no proof, only a whisper, a possibility so faint that most people would overlook it. But you don't. You've learned that the smallest hints can hold the deepest truths. The scientists studying the data describe this faint line as a suggestion of complexity, not certainty, not evidence, just a soft suggestion. You like that phrase. It feels honest, it feels gentle, and tonight gentle feels right. The chemistry of the fragment also reveals another detail. The break exposed layers with slightly different densities, suggesting the object might have grown gradually over time. Dust settling on dust, ice forming on ice, layer after layer of ancient material, building a quiet history, one particle at a time. You imagine that slow accumulation, a snowflake drifting across galaxies, gathering fragments from the breath of dying stars, carrying each grain like a memory. And then after all that time, after all that quiet, the surface cracks, and everything hidden finally meets the light. You lie there in the dark, feeling that idea open inside you, that sometimes the moment you break is the moment your truth shines through. The chemistry inside 3IATLAS should not have survived this long. Its volatiles should have evaporated. Its complex structures should have collapsed. Its isotopes should have decayed past recognition. But they haven't. They endured. They waited. They held their shape in a universe that forgets almost everything. And now, in this quiet night, the fragment is revealing a story older and softer than anything you expected. A chemistry that should have been impossible. Yet here it is spinning gently beneath the sunlight, whispering its impossible truth in colors only the patient will ever hear. The night around you feels even softer than before, as if each moment is folding itself into the next, with the same quiet patience that guides drifting fragments through the dark. You lie there breathing slow, feeling your thoughts stretch outward like faint ripples reaching toward a distant shore. Somewhere in that distance, the smaller fragment of 3IATLAS continues to turn in the sunlight, its newborn brightness defying everything astronomers expected. Most celestial fragments fade after breaking. You would think of dust scattering surfaces, darkening materials, losing their ability to reflect the weak sunlight they receive. But not this one. This fragment refuses to dim. Even days after the fracture, it shines with a strength that feels almost stubborn, as if the universe carved a secret into its new face and the light is trying delicately to reveal it. Astronomers first noticed the anomaly when comparing the albedo data between the two fragments. The larger piece, old worn steady, reflects sunlight in shallow patterns, typical of interstellar ice, weathered by cosmic radiation. But the smaller one scatters its light with a clarity that seems to rise every time it rotates. Its brightness curve does not soften with time, it sharpens. Each rotation reveals another gleam of fresh ice, another patch of crystalline surface, untouched by the erosion that dims most wandering bodies. You imagine standing near it, watching these flashes appear like tiny sparks on cold stone, appearing and disappearing in a rhythm too delicate for anyone to predict. The fragment spins faster than the original object, a result of angular momentum redistributed during the break. That faster spin means sunlight kisses more surface area in less time, each moment illuminating a new part of its interior. But the scientists studying it know there is more happening here than just rotation. The brightness trends are too clean, too persistent, too gentle to be explained by mechanics alone. They suspect the fragment's interior contains surfaces that have never been exposed since the object first formed surfaces with reflectivity, close to theoretical maximums for certain types of crystalline ice. Ice is so pure that it returns nearly every photon it receives. You breathe softly, letting that image settle in your mind. A piece of the universe, so untouched, so ancient, that it reflects light as though it has been waiting billions of years to be seen. Some researchers describe it as fresh light, a term normally used for newly exposed regolith on asteroids or moons. But here the phrase feels deeper, almost spiritual. Fresh light from an object older than the stars you see above your house tonight. There is something quiet about that, something humbling. The smaller fragment's brightness isn't just consistent. It oscillates, but in patterns that seem too elegant for randomness. A rise, a fall, a shimmer just slightly brighter than the previous day, as if the fragment is breathing light. You wonder what it would feel like to hold something that breathes light instead of air. Some nights, astronomers talk about the fragment as if it were alive, not literally, but in the way it reacts to sunlight, heat rotation, exposure. Objects don't choose their behavior. But that doesn't stop the human mind from feeling affection for something so delicate. The thermal data shows that the new surfaces heat and cool faster than expected. This suggests that the inner layers are not compact and dense like typical cometary material, but porous, a labyrinth of tiny channels where heat can travel freely. This structure allows the fragment to radiate heat quickly, preventing it from overheating and losing its brightness. A self-preserving quietness, a balance found only in objects that have spent millions of years learning how to survive. You lie there, thinking of the hidden architectures inside that tiny shard of ice. A landscape of crystals pours voids, all whispering their stories through the way they reflect the sun. There is another detail that surprises researchers. The fragment appears to have a slightly different color profile from what it showed when it was still part of the larger body. Not dramatically different, not enough to draw attention in a casual glance, but enough. A faint shift toward a bluer tone in the reflectance curve. A suggestion that the new surfaces contain materials that scatter shorter wavelengths more efficiently. This kind of shift is often seen in icy moons with freshly exposed surfaces, where solar radiation has not yet had time to darken the ice. But 3IATLAS comes from nowhere near any moon. Its home may have been a star system long gone. Its village of origin may have been erased by supernova winds or swallowed by gravitational tides. Yet here it is shining softly in a color that feels like the memory of a long-lost world. Some astronomers have even suggested that the smaller fragment may have been part of the core, a region shaped under conditions different from the outer shell. A region that condensed first, that cooled slower, that trapped more volatile compounds in its crystalline structure. If this is true, then the brightness is not a coincidence, but a truth. The fragment shines because the universe preserved a deeper part of it until this exact moment. You breathe in slowly, letting your own chest rise with the quiet rhythm of the thought. There is a feeling here, not excitement, not fear, but recognition. Because you know that sometimes the parts of you that shine the most are the parts you didn't reveal until life cracked you open. The fragment's path also shows a tiny drift away from the larger piece. Not a dramatic divergence, not a sudden recoil, just a soft easing into its own direction, as though the break set it free to follow its own momentum. Astronomers have measured this slight trajectory shift with precision instruments, but numbers alone don't capture the feeling of it. The feeling of finally moving in a direction that belongs only to you. The fragment does not rush. Its brightness does not falter. Its rotation does not wobble in the chaotic way freshly broken bodies often do. Instead, it settles into a rhythm that feels almost like calm, a new equilibrium, a new identity found in the aftermath of a quiet rupture. You let your breath slow, matching that rhythm, feeling yourself drift with the fragment through the soft dark. And somewhere far away, in a place without air or sound, a tiny piece of ancient ice refuses to dim, refuses to fade, refuses to be anything other than what it finally is. A truth you can only see when the light hits it in just the right way. The darkness around you feels almost liquid now, like a calm river the night has poured itself into. You breathe slowly, letting that stillness wash through your body in the same soft rhythm that guides the drifting fragment of 3IATLAS far beyond the edges of your world. Even after the fracture, its two pieces continue to move along the same ancient path, but not quite the same. There is a rule in celestial mechanics, one so simple that even children understand it without trying. Objects move the way gravity tells them to. They orbit, they drift, they obey. But the smaller fragment of 3IATLAS carries inside it a story old enough to bend that rule just slightly, just enough to make the numbers hesitate. Astronomers first noticed the anomaly when they compared the predicted trajectory with the actual motion captured in nightly observations. The difference was tiny, microscopic, almost petty in the vast emptiness of space. A shift of a few thousandths of a degree. A drift that would hardly matter to anything larger than a whisper. But in astronomy, small shifts become enormous distances with time. You imagine looking at the graphs, thin lines drawn with precision numbers, lined up neatly across the screen patterns that make sense until something doesn't. The predicted path of the fragment is smooth, steady, mathematical, but the real path tilts ever so slightly like a leaf turning with a breeze no one can feel. Some scientists believe the discrepancy was just measurement noise. Others blamed instrument calibration software, smoothing solar radiation pressure. But the longer they watched, the harder it became to deny the truth. The fragment was moving in a way the equations did not predict. Not dramatically, not chaotically, just differently. You sense the subtle beauty of that, the idea that even in a universe full of laws and rules and constants, there are moments when something refuses to follow the script. NASA researchers studying the residuals noticed that the motion correlated with the fragment's rotation. Each time it turned its path shifted by a whisper of acceleration, a non-gravitational force, not powerful, not dangerous, but present. Light itself can push objects in space, a phenomenon called radiation pressure. Most objects barely respond. They're too heavy, too massive, too unyielding. But this fragment is small light and freshly exposed. Its surface, still shimmering with new ice, reflects sunlight with extraordinary efficiency. And that reflectivity creates a tiny push each time the sun's rays strike the crystal layers at just the right angle. You imagine it now, the sunlight touching the fragment, nudging it gently, the way a soft breath might nudge a feather. A force almost too delicate to be real. Yet it is real, and over thousands of kilometers, the cumulative effect becomes measurable. This is the same phenomenon that once puzzled scientists studying 3IATLAS, an object that drifted just slightly differently from what gravitational models predicted. But 3IATLAS isn't behaving the same way. Its motion is smoother, more rhythmic, strongly tied to its rotation period. As it spins, each facet of ice reflects sunlight differently, sending tiny pulses of motion into the void. It's like watching a dancer move across a stage with steps so small you don't notice them individually, only the slow drift from one side to the other. You lie there for a moment, letting that image settle, a piece of ancient ice dancing softly in a place without sound. Scientists also noticed another clue. The fragment's rotation period changed slightly after the fracture. Not enough to alarm anyone, but enough to change how sunlight interacts with its surface. Angular momentum redistributes when objects break, and the smaller piece spins faster, now exposing more of its reflective surface through each rotation. More reflection means more radiation pressure. More pressure means more motion. More motion means equations begin to strain. You think of the times in your own life when small changes grew into something larger, a shift in perspective, a quiet decision, a movement, so gentle you only understood it later. The universe works like that too. It whispers change before it shows it. Another factor in the fragment's unusual motion is its mass distribution. Fresh breaks expose irregular interiors, pockets of porous ice, clumps of dust voids where heat travels freely. This uneven structure makes the fragment react to solar radiation in asymmetric ways, like a little sail unfurling in different directions depending on how the light touches it. Some models call this the Yorp effect, a subtle phenomenon where uneven reflection changes the spin rate and trajectory of small bodies. You don't need the technical name to feel its poetry. A single ray of light pushing gently against a surface that hasn't known brightness in countless ages. A single touch changing the course of something ancient. It makes you wonder how many small touches in your own life have nudged you in directions you didn't realize you were headed. The scientists analyzing the motion noticed something else, something stranger. The deviation was not random. It had pattern, structure, a soft rise, a gentle drop, a drift that mirrored the brightness variations in the fragment's light curve, as if the motion and the light were speaking to each other. Some called it coincidence, others called it noise. But the ones who stayed up late staring at the data with tired eyes and stubborn hope knew better. The fragment was telling them something, not in words, not in behavior meant to be understood, but in the simple truth that when something ancient breaks, its pieces learn new ways to move through the world. You breathe softly, letting that idea open inside you, that after breaking motion becomes a form of expression. The scientists ran simulation after simulation trying to replicate the drift. They adjusted mass rotation shape density. Nothing matched. Because the universe never reveals its secrets to equations alone. Some truths must be felt before they can be understood. In the days that followed, the motion of the fragment continued shifting with the same soft insistence. Not wild, not erratic, just different. A gentle deviation that speaks of an internal history still unfolding, a quiet defiance of predictable paths, a reminder that even the smallest bodies carry stories strong enough to bend the mathematics that try to define them. You relax deeper into the darkness, feeling your breath sink with the slow persistence of that drifting fragment. And somewhere far away, wrapped in sunlight, older than language, that tiny shard of a broken world continues moving the way only it can steady, softly and visibly rewriting the equations meant to contain it. The night wraps itself a little closer around you, the way a blanket settles over tired shoulders. And somewhere inside that quiet warmth, your thoughts drift outward again toward the tiny fragment of 3IATLAS that continues its slow, silent journey through the breathless dark. After the fracture, the smaller fragment revealed its chemistry, its brightness, its impossible purity. But there is something else that only becomes clear when astronomers look not at its light, but at its temperature, the faint warmth it gathers and releases as it turns beneath the sun. Temperature is one of the softest truths in astronomy. It doesn't shout, it doesn't flare, it doesn't leave dramatic trails across the sky. It whispers in tiny changes that tell stories older than starlight. You imagine holding the fragment in your hands, not literally, but in the quiet way the mind holds an idea. Feeling the cold rise through your palms, feeling how the ancient ice resists the warmth around it, the way some people resist comfort after too many years in the dark. When sunlight touches the fragment, the temperature rises by barely a fraction of a degree. Numbers so small you could mistake them for instrument noise. But ice that old behaves differently from anything you've felt before. It changes slowly, stubbornly, like a memory that refuses to thaw. Researchers noticed that the sunlit side of the fragment warms quickly, much faster than cometary models predict. And then just as quickly the surface cools when it turns back into shadow. This behavior is unlike most bodies in the solar system. Asteroids heat slowly and cool slowly. They're dense stone holding warmth, the way walls hold afternoon sun. Comets warm faster, but retain enough heat to glow faintly on the dark side as the stored energy bleeds out. But this fragment does neither. It heats fast, cools fast, like glass that has forgotten how to hold temperature. Why? Because the freshly exposed surface contains ice structures that have been untouched for longer than humankind has existed. Crystals with microscopic boundaries that conduct heat like pathways waiting to open. Layers that once formed under pressures near absolute zero, where molecules arrange themselves in delicate lattices that crumble easily in warmth but reform as soon as the cold returns. You lie there, imagining the fragment turning its warm side, facing away its heat, vanishing back into the void, as if it had never been there at all. It reminds you of the way certain feelings come and go, quick flares of warmth that disappear as soon as the moment passes. One study estimated that the thermal inertia of the fragment is close to that of ultra-porous ice, filled with tiny voids that act like miniature lungs exhaling warmth with each rotation. Porosity so extreme that heat cannot settle, cannot linger, cannot cling to the surface long enough to melt or transform it. A body full of spaces that let warmth pass through instead of holding it. You think about that, how vulnerability sometimes looks like emptiness, but is really just the ability to let things pass through without being destroyed. The temperature readings also reveal something unexpected. The night side of the fragment is colder than models predicted. Even objects far from the sun retain some warmth on their shaded sides, a faint thermal memory of the day's light. But the fragment loses heat nearly instantly, returning to its baseline temperature, like breath fading into cold air. This suggests that the internal structure is not dense or uniform, but delicate, a network of microcrystals capable of shedding energy with remarkable efficiency. Some astronomers propose that the fragment contains super volatile pockets, tiny reservoirs of ancient gases that absorb and release heat in unpredictable ways. Others focus on the possibility that its interior may contain exotic ice phases, forms of ice, that only exist under extreme pressure and near zero temperatures. Ice 2, Ice Phi, Ice Ii. Names that sound like chapters in a forgotten story, each one representing a different way for water molecules to hold hands in the cold. These phases aren't found naturally on Earth. They appear only in the deep chill of distant moons and interstellar wanderers that have never known warmth. You imagine such ice cracking open for the first time, its structure shifting as it meets temperatures it has never felt before. The sudden warmth from the sun would cause microshocks inside the fragment, tiny rearrangements that alter how heat moves from one side to the other, small shifts that add up to an entirely new behavior. The more the fragment turns, the more clearly scientists see the temperature dip on its shaded side. This dip is sharper than expected, a sign that the new surfaces cool so fast they reach equilibrium with the surrounding void almost immediately. You think about the surrounding void, a place where heat has nowhere to go except away. A place where warmth evaporates the way breath does on a winter morning. The fragment's fast cooling isn't a sign of weakness, it's a sign of purity. Ice that clean loses heat, like a perfect mirror loses light. The thermal data also reveals a slight asymmetry. One side cools faster than the other. This could be due to uneven thickness, different crystal structures, or pockets of dust, absorbing photons in small bursts. But whatever the reason, the fragment's cooling curve is a signature, a fingerprint of a history that spans galaxies. You lie there in the dark, feeling your own body cool as your breath slows, mirroring the way the fragment drifts into its shaded half. Another discovery emerges from the thermal analysis. The core temperature is slightly higher than the surface temperature, even after cooling. Not by much, just enough to suggest that the interior is insulated by layers that still remember the heat of their formation. Heat from a star that may not exist anymore. Heat carried across millions of years of silent drifting. a faint ancient warmth still breathing inside a fragment smaller than a mountain. You think about that warmth, how something can carry a piece of its origin for longer than anyone expects. The thermal models also hint at another possibility, that the fragment's interior might contain complex organics that absorb heat differently from the surrounding ice. These compounds, formed in the cold chemistry between stars, can act like tiny sponges, soaking up sunlight and releasing it slowly in spectral whispers, too faint to see. Not life, not even close. Just the raw ingredients, the alphabet from which nature sometimes tries to write. Even the possibility feels soft in the quiet of your room. Finally, there is the question of why the fragment remains colder than similar bodies. Some suggest it's simply small mass. Others believe the ice is too clean to hold heat. A few push the idea that internal voids allow cold to spread rapidly throughout its structure. But maybe there's another answer, one less scientific, but no less true. Maybe some things remain cold because they have spent so long in the dark that warmth feels unfamiliar, not frightening, just new. And new things take time to settle. You lie there, letting your own warmth settle inside your body as the night wraps around you with the softness of something ancient and kind. Far away, the atlas drifts through a light too gentle to ever melt it completely. And in the dance between warmth and cold, between sun and shadow, the fragment continues to reveal its truth. A truth written in temperatures so small they are almost silence. But sometimes silence is the clearest language the universe speaks. There is a special kind of quiet that follows deep, cold. A quiet so complete, it feels like the universe has folded itself into a single steady breath. As you lie there in the soft, dark breathing slowly, you can almost feel that breath drifting toward you from the far reaches of space, where the fragment of 3IATLAS carries a story older than memory. Temperature tells one kind of truth, light tells another. But composition reveals the history a thing cannot hide. And in this fragment, the chemistry hints at something astonishing, something so old and so violent that scientists pause before writing it down. A trace of supernova. Not the explosion itself, not the fire, not the shock wave that can tear a star's skin open and scatter its bones across a galaxy, but the residue, the quiet dust, the leftover particles that survive the blast and drift for ages until they become part of something new. Astronomers call these remnants supernova fossils, materials shaped by the last breaths of dying stars. You breathe softly, letting that truth settle in you, that the fragment turning in sunlight might contain the ashes of a star that once burned brighter than anything in your night sky. The spectral fingerprints revealed faint signatures of isotopes that do not form in calm environments. They require heat far beyond what planets can make pressure, beyond what comets endure, an energy that only exists inside the furious heart of a star at the moment it dies. Iron in a particular ratio, nickel in traces that shouldn't survive billions of years of cosmic wandering, and a tiny whisper of silicon shifted in a way that suggests the material once passed through temperatures hot enough to vaporize worlds. You lie there, imagining that moment, a star collapsing on itself, the core igniting in an instant, a roar of photons and plasma erasing everything in its path. And somewhere in that storm, a shard of matter refuses to be destroyed. It's thrown outward at unimaginable speed into the interstellar dark, not chosen, not protected, just lucky enough to land in a quiet pocket of the explosion, dense enough to survive, cold enough to stabilize once the fire has passed. Those lucky pieces travel for millions of years until gravity steals them, or ice binds them, or they merge with dust to form the seeds of a new interstellar object. You think about survival like that, the kind that isn't a victory, but a quiet persistence. The spectral analysis shows another clue, an unusual ratio between stable iron isotopes and heavier elements. This ratio matches what scientists see in particles collected from meteorites that predate the solar system particles formed in the shock waves of ancient supernova that lit the early galaxy like brief lanterns. So when the fragment glows, its light carries a faint echo of a star's last scream. But the echo is soft now, a whisper shaped by ice reflected through calmness, filtered by ages spent drifting in the dark. Some researchers found hints of short-lived radionuclides elements that only persist when locked away in stable materials. Their presence suggests that the material must have cooled rapidly after the explosion, freezing the isotopes in place before they could decay away. That cooling could only happen if the material escaped the blast at exactly the right moment, not too soon, not too late. A narrow window between destruction and preservation. You breathe in deeply, letting your chest rise with the strange comfort that comes from knowing even stars have narrow moments of survival. There is a detail scientists rarely mention out loud, without pausing. Certain patterns in the spectral lines resembled signatures seen in supernova remnants of Type II origins, explosions of massive stars that once held more than 8 times the mass of the Sun. Massive stars live violently and die young, burning through their fuel in a fraction of the time smaller stars take. Their deaths seed galaxies with the elements that create planets, oceans, air life. So when you trace the quiet signature inside 3IATLAS, you are tracing the legacy of a star that died long before any human eyes ever opened. And yet its dust is here now in this tiny fragment, reflecting sunlight in a way that lets you witness its memory. The researchers also consider the possibility that the fragment passed through multiple shock waves over its lifetime, not just the one that created its material. Shock waves are the galaxy's sculptors. They compress dust clouds, ignite star formation, and sometimes shape interstellar bodies through pressure so intense it rearranges atoms. The faint distortions in the fragment's spectra could be the fingerprint of such pressures. Tiny alterations in atomic spacing, minute bending of crystal structures, patterns that speak of forces strong enough to erase time. You picture those shock waves moving across space, giant ripples that make planets and break them, that bake matter into new arrangements and then fling those arrangements into the dark. The fragment survived those waves, traveled through them, carried their memory, just as you carry the moments that shaped you, not in scars, but in the quiet patterns woven into who you are. Some astronomers say the fragment may include material older than the Milky Way itself, grains forged in the atmospheres of ancient stars from galaxies the newborn universe barely remembers. These grains drifted through the galaxy before being caught in a cloud that eventually collapsed to form something. A star, a cluster, an object, a wanderer. Perhaps even the parent body from which 3IATLAS broke away. If that's true, then the fragment is not just ancient, it is primordial. A survivor from a time when galaxies were still deciding what shapes they wanted to take. You lie there quietly, letting the idea sink into you like warm water, that a tiny shard of ice floating in the dark might carry the oldest story you have ever touched. The scientists studying it know they may never fully decode its chemistry. The fragment is too distant, too fragile, too transient. But the traces they do see are enough to paint a picture in whispers. A picture of a body born in fire, tempered in shock waves, cooled in darkness, and revealed only because it finally broke. You exhale softly. Sometimes breaking is the only way for ancient light to reach the surface. And somewhere far away, that tiny piece of a shattered world continues to drift, carrying in its silent glow the fossil of a star that once burned so brightly it shaped everything that came after it. There is a kind of stillness that settles over you once you've wandered far enough into the quiet of the night. A stillness that feels almost like listening to an old song you barely remember, but somehow know by heart. As you lie here in that softness, your mind drifts once again toward the fragile fragment of 3IATLAS, still glowing with the faint memory of the star it once belonged to. The chemistry has revealed its past, the brightness its hidden interior, the motion its new freedom. But there is something else, something no one expected. Something that caught even the most seasoned scientists in a pause. The realization that the mathematics describing 3IATLAS no longer behave. Equations that worked yesterday begin to hesitate today. Models stretch like fabric pulled too tight. Numbers wobble in ways they shouldn't. It begins quietly, a few data points, disagreeing with the predicted path. A tiny deviation from a curve that should have been perfect. In astronomy, a small deviation is often noise, a gust of solar wind, a measurement error, a correction waiting to be made. But this deviation grows, not wildly, not dramatically, just persistently. Astronomers try to fit the fragment's behavior into established equations, like pressing a shape into a mold it was never meant to fill. But the fragment resists softly, gently, without defiance, as though it simply remembers a truth that the equations do not. You imagine touching the numbers with your fingertips, feeling the quiet imbalance beneath them, the way you sometimes feel when your own certainty doesn't quite match reality. The first models to fail are the photometric predictions, the ones meant to forecast how bright the fragment will be as it rotates. Those predictions rely on smooth surfaces, consistent reflectivity, and known materials. But the fragment is none of those things. Its surface is new, its crystals are strange, its structure, a mosaic of pressures and temperatures that no comet in your solar system has ever known. So the light refuses to follow the math. Instead, it flickers in soft rhythms that feel almost personal, like a heartbeat the fragment has rediscovered. Then the orbital equations begin to drift. Tiny shifts in acceleration, sculpted by radiation pressure mass distribution, and the fresh asymmetry left by the fracture. These are forces that mathematics can describe, but only if everything else remains predictable. And nothing about the fragment is predictable now. It warms faster than expected, cools faster still, reflects differently from one tiny patch of ice to the next. You lie there, feeling the night around you, as the fragment drifts through sunlight, a piece of ancient memory, moving in ways no equation can quite follow. The astronomers try everything revised. Yorp models non-gravitational acceleration terms, radiation pressure, coefficients adjusted for crystalline ice. But the fragment keeps slipping through the math like a thought you can't put into words. Some of the researchers begin to speak softly about chaotic tumbling, a phenomenon where an object's rotation becomes unpredictable due to irregular shape or uneven mass distribution. But this fragment isn't tumbling. Its rotation is steady, calm, almost graceful. It's the motion around its spin that breaks the patterns, a slow precession, a shifting tilt, a gentle wobble that suggests an interior still adjusting after the fracture. It's as if the fragment is learning how to move again. And yet, despite all this complexity, the scientists notice something almost poetic. The deviations are not random. They follow a soft order that feels like listening to a message in another language, a rhythm that means something, even if the words are missing. You breathe in, feel the softness in your chest, and realize that this is what it's like to watch mathematics fail in the presence of something ancient. The models stretch again. Thermal equations predict one behavior, but the data shows another. Reflectance models insist the brightness should fade, but it continues to rise and fall in patterns no one expected. It's not that the fragment is breaking the laws of physics. Physics remains unchanged. Truth remains truth. It's that the fragment carries inside it conditions so specific, so rare, so shaped by time and pressure and cosmic violence that no human equation fully understands it yet. Sometimes it takes centuries for mathematics to catch up to what the universe already knows. You think about that, how often you've tried to define yourself with rules or numbers that never quite fit. Maybe some things aren't meant to fit. Maybe they're meant to reveal that you're larger than the equations that try to describe you. Another unexpected detail emerges from the data. The fragment's rotation rate isn't constant. It speeds up in tiny increments when warmed by sunlight and slows down in the shadows. This thermal torque effect is known in small bodies, but the fragment's behavior is too clean, too patterned, too precise, almost deliberate. In the observatory logs, one researcher wrote, "It turns like it remembers something." A poetic line, but a true one. Its motion is the sum of every force that has ever touched it. Radiation, gravity, impact, pressure, fracture. A history written not in language, but in tilt and spin and drift. You lie there, feeling the weight of that thought, feeling how the fragment's motion echoes the way your own life has turned, sometimes steady, sometimes uncertain, sometimes shifting for reasons you couldn't see. When mathematics fails, it's not the universe that is wrong. It's our understanding that is incomplete. And yet there is beauty in that incompleteness, because it means we are standing at the edge of discovery in a quiet place where new truths wait to be learned. The fragment drifts on, carrying its impossible motion, like a soft hum against the silence of space. It doesn't know it has become a puzzle. It doesn't know its path breaks predictions. It doesn't know it has pulled scientists into long nights of staring at curves that don't behave. It simply moves the way it must, shaped by the physics of a past, older than the equations trying to hold it. You breathe again, slow and warm, and the room feels a little more spacious, as if the universe has opened a door to something new. Somewhere far beyond Earth, the fragment continues its gentle deviation, slipping past the boundaries of human mathematics, with the quiet confidence of something ancient finally moving in its own way. The night around you feels heavier now, not with weight, but with depth, as though each breath you take pulls you a little closer to the quiet truth of everything drifting above your world. The smaller fragment of 3IATLAS has held your attention with its impossible brightness, its ancient chemistry, its unpredictable motion. But there is still the larger one, the half that remained steady, silent, dim, as though it accepted the fracture with the patience of something that has known far too many endings. Most of the mass stayed with this larger fragment. It continues along the expected path, moving exactly where the equation said it would, as if nothing unusual ever happened. But that stillness is its own mystery, because the larger fragment did not simply remain the same. It changed too, but quietly, subtly, in a way that only instruments and long nights can reveal. You imagine it drifting now, its surface, older, darker, marked by the scars of cosmic radiation and interstellar wandering. Unlike its brighter sibling, this fragment does not glow. It does not flicker. It does not make equations falter or models hesitate. It simply moves. But an object does not lose half of itself without something shifting deep within. The first sign was a slight decrease in brightness, just a few percent, barely enough to catch the eye. Most bodies brighten when they shed mass, their fresh surfaces exposed to sunlight. But the larger fragment dimmed. This dimming suggests that the break did not expose fresh ice on this fragment's surface. Instead, the fracture line left behind a jagged, irregular scar, a surface too rough to reflect light efficiently. Astronomers call this a low albedo scar. You feel the phrase settle inside you like a quiet ache, a reminder that not every wound reveals something bright. Some simply hold on to more darkness. The shape of the larger fragment also changed, not dramatically, but enough to alter how it rotates. Its spin slowed slightly, as if the loss of mass made it exhale and settle into a gentler motion. Objects in space rarely slow down without cause. But here, the redistribution of mass shifted the moment of inertia, the same way a figure skater slows their spin when they extend their arms. You imagine the fragment doing this in the cold light of the sun, relaxing, opening itself, letting the universe turn it in its own slow rhythm. As it rotates, its older, darker surface absorbs more sunlight than the new ice of the smaller piece. This means it warms slightly faster on the sunlit side, but retains some of that heat long after it leaves the light. Thermal inertia, a kind of memory. Old surfaces remember warmth longer than new ones. You think about how memories sometimes linger in you too, not because you want them to, but because time has pressed them deep. The larger fragment's temperature curve is smoother than its siblings, showing no sharp cooling dips, no rapid fluctuations. Instead, it warms, holds the warmth, and lets it fade with slow inevitability, a steady heart beating in the cold. But the most intriguing detail is not its temperature. It is its trajectory. While the smaller fragment deviates gently under the influence of radiation pressure and uneven surfaces, the larger one continues almost exactly as predicted. Almost. Astronomers noticed a subtle outward drift, a widening of its hyperbolic path by a margin so small it took weeks to confirm. This drift is likely caused by mass loss from the fracture. When a body loses weight, its motion changes just slightly, a redistribution of momentum that sends it outward by a quiet, invisible push. Not enough to break predictions, but enough to remind the scientists that even silence changes things. You let that thought rest in you, that silence is never truly still. Another feature emerges from the observations, a faint cloud of dust trailing the larger fragment, barely visible, almost ghost-like. This dust is not from a violent explosion. It is simply the residue of the break-tiny particles shaken loose by the sudden loss of tension. The solar wind carries them away slowly, stretching them into a thin, pale ribbon that fades with each passing day. You imagine that ribbon floating in space, drifting behind the fragment, like a scarf let go in the wind. Traces of the past, unraveling gently as the present continues forward. The interior of the larger fragment remains unexposed. Its surface has been weathered for ages, darkened by cosmic rays, hardened by cold, sealed against warmth. So, its chemistry remains hidden. No new spectral lines, no revelations, just the familiar signature of irradiated ice and dust carried across galaxies. But there is beauty in the things that remain unchanged. A certain grace in the quiet persistence of a body that does not need to reveal anything to be understood. You lie there feeling the slow pulse of silence in your own body and realize that the larger fragment holds a different kind of story, not one of revelation, but of endurance. Its motion is stable, its rotation calm, its brightness steady, its path predictable. And yet you sense something soft in that predictability, a reminder that not every part of a story needs drama to be meaningful. Some truths arrive quietly, in steady movements, that only become profound when you step back and see the whole picture. The larger fragment carries most of the mass, most of the history, most of the ancient pressure that shaped 3IATLAS through billions of years. It drifts on like a slow, deep breath, leaving a body that has held tension too long. In its silence, in its steadiness, in its refusal to fracture further, it holds the shape of what remains after change. The small fragment is the spark, bright, restless, full of revelation. But the larger one is the anchor, quiet, grounded, carrying the weight of everything that did not break away. You breathe in, feeling both halves of that truth rest gently in your chest. Some parts of you shine brighter after breaking. Others stay the same because they must. Both are real, both are needed. And somewhere far away, in a silence, older than any memory, the two fragments continue drifting. One luminous, one steady, each carrying the story of what was lost, what was revealed, and what remained. The night around you feels stretched thin with quiet, as though every sound has softened to make room for the story unfolding far beyond Earth. You lie there, breathing slowly, and somewhere in that breath you feel the distance widening between the two fragments of 3IATLAS. Not violently, not abruptly, just gently, like two lanterns drifting apart in a dark river. The smaller fragment, still shimmering with new light, turns with bright insistence, its fresh surface catching sunlight as though awakening to the idea of itself. The larger one moves steadily unchanged in its softness, carrying the deeper weight of the object's long and ancient past. And between them is silence, not absence, not emptiness, just a quiet space where something old is loosening its hold. Astronomers measure the widening distance with precision fractions of kilometers, at first, then tens, then hundreds. But numbers cannot capture the feeling of that separation. Because space does not separate things the way gravity does on Earth. Out there, distance is a kind of language, a slow unfolding of memory, momentum, and truth. You imagine watching the fragments from nearby, feeling no wind, no sound, no pull, only the visual drift, steady and soft, as if the universe is gently turning a page. The silence between them contains more history than either fragment does alone. For millions of years, both pieces were part of a single body, a single structure, a single trajectory, a single quiet purpose. Whatever shaped them, whatever pressed them, whatever froze them into the chemistry you studied earlier, it shaped them together. They endured supernova winds together. They drifted through interstellar voids together. They carried their impossible chemistry through dark ages together. They only separated once in the moment you witnessed, through flickers of light and faint shifts in brightness. Now that separation is complete, and the story continues in the space between them. One of the first observations scientists made was how differently dust behaves around each fragment. Tiny grains released during the fracture spread into the silence between them. Not evenly, not predictably, but in soft currents created by their rotations. Some of the dust falls behind the larger fragment, like a thin shadow that stretches across emptiness. Some gathers in a faint veil around the smaller fragment, catching sunlight in pale gold flashes, so quick you'd miss them if you blinked. And some dust simply floats in the narrowing vacuum between them, quiet, unclaimed, almost contemplative. It creates a faint bridge you can only see when the sunlight hits just right. A bridge of what once was, stretching across the space between what is now. You lie there thinking about the dust and how it mirrors the way people leave small traces of themselves in the spaces they drift away from. As days pass, the space between the fragments widens. The smaller fragment, carried by its reflective surfaces and altered momentum, drifts outward on a slightly broader arc. The larger one continues steadily unbothered, unhurried, holding its course like a deep ancient memory that doesn't need to change. This widening distance creates a dynamic astronomers call differential divergence, a technical term for something that feels much more emotional when you imagine it. Two bodies, once one carrying different futures into the dark. You breathe out slowly, feeling something gentle in that thought. Another quiet truth emerges when scientists analyze the gravitational interaction between the fragments. At first, they still influence each other, just slightly, like two thoughts lingering in the same mind. But as the gap widens, their pull weakens, their connection thins, their orbits become more themselves and less each other. Astronomers can map the exact moment that mutual gravity drops below a measurable threshold. But what matters is the feeling of it. There comes a point when two bodies stop shaping each other's paths, not abruptly, not with a spectacle, but softly, like a breath being released. You lie there, letting that truth settle inside you with the weight of something familiar. The silence between the fragments also reveals another shift. The small fragment's brightness no longer affects the photometric readings of the larger one. They are now two independent lights in the same sky, one steady, one shimmering, neither diminishing the other. This is when astronomers stop referring to them as the parent body and its piece, and begin calling them simply Fragment A and Fragment B, names given not to divide them, but to recognize their separate futures. The silence grows, not cold, not lonely, just vast. Inside that silence, the universe is rearranging what once belonged together. Some scientists argue that the fragments may never meet again. Their trajectories are too wide, their paths too distinct. Others suggest they might pass near each other, in some far future, a silent crossing in the dark, with no memory of their shared origin. But one truth remains: whatever shaped them, whatever broke them, whatever set them drifting, that story lives in the space between. The silence becomes a kind of echo, not of sound, but of everything neither fragment carries alone. You lie there in the stillness of your room, feeling the same kind of quiet grow inside you. A quiet that isn't emptiness, but understanding. A quiet that holds the truth that distance does not erase what was shared. It only reveals what remains. And somewhere far beyond Earth, where sunlight falls in faint sheets across ancient ice, two fragments continue their slow drift bound, not by gravity, not by touch, but by a history carved into both in equal measure. A history written now in the silence that widens between them with every passing night. The night around you feels softer than ever, as though every shadow, every quiet corner of your room is leaning closer to listen. And somewhere in that stillness, your thoughts drift back to the two fragments of 3IATLAS, slowly parting in the vastness above. One bright, one steady, and the silence between them widening like the surface of a calm sea. But time and space does not feel like time on Earth. There is no dawn or dusk, no ticking clocks, no winds to hurry anything along. Only motion gentle patient guided by momentum laid down millions of years ago. And as days turn into weeks, astronomers begin to see what this slow separation really means. The smaller fragment, still carrying its impossible glow, continues drifting outward on a widening curve. The larger one keeps to its ancient trajectory, holding a path that once belonged to both of them. You lie there feeling the softness in your breath and realize that what you're witnessing is a kind of goodbye, the kind that unfolds so slowly you don't notice it happening until the distance feels like forever. In the data, the growing gap between the fragments shows up as a simple number. But numbers cannot explain what the universe is whispering in that long, quiet drift. Astronomers call this stage divergent propagation, when two bodies born of the same object carry their separate futures along paths that will never meet again. Yet even as they drift apart, traces of their connection remain. The dust veil that lingered between them begins to thin, stretched by the solar wind, carried into streams that scatter like faint trails of forgotten thoughts. Some particles follow the larger fragment, some the smaller. Some float free, suspended in the dark, like tiny memories with nowhere to go. You picture these dust grains as the last shared breath between two drifting beings, released softly without resistance. Astronomers also observe a subtle shift in the smaller fragment's spin. Its rotation grows a little more, even as if the fragment is settling into its new identity, finding a balance it couldn't hold when it was still part of something bigger. The larger fragment keeps its slow, deep spin, unbothered, ancient, carrying the weight of what it has always been, and the silence between them becomes a shape of its own. As the fragments travel deeper into the solar wind, the environment changes. Charged particles streaming from the sun brush across their surfaces, nudging dust, altering micro-temperatures, sculpting faint ion tails so thin they barely register in the instruments. But the scientists notice, the smaller fragment develops a faint blue-white ion tail, not dramatic, not comet-like, just a thin breath of charged gas that flows behind it like a strand of cold silk. The larger fragment shows almost nothing, only a faint haze that disperses quickly, as if refusing attention. You imagine seeing both fragments through a telescope, two tiny flecks of ancient ice drifting in opposite directions, one shimmering with youth, one fading softly into the dark. It feels like watching a long goodbye written in starlight. The gravitational influence between the fragments continues fading. They no longer shape each other's paths. Their future positions can be calculated independently without accounting for the other's presence. Mathematically, they have become separate objects. But emotionally, if you can call it that, there is still something connecting them. Because every trajectory is shaped by what came before. Every path remembers the moment it changed. The larger fragment will carry a slight outward tilt, an imprint of losing half its mass. The smaller fragment will carry a subtle acceleration, a signature of its reflective new surface. Both of those changes were born in the same moment. Both carry the shape of the same break. You breathe softly. That thought settles in you like warmth. Even when things drift apart, they carry the fingerprint of the moment they separated. As the fragments continue outward, the background changes. The sun becomes smaller. Light takes longer to reach their surfaces. The warmth weakens. Shadows grow sharper. and slowly the fragments begin to fade. Not because their brightness dies, but because distance dims everything. The smaller fragment still flashes briefly each time its reflective face catches sunlight, a signal so small it looks like a heartbeat in the telescope readings. The larger fragment remains steady, a dim ember of ancient ice gliding outward with the calmness of something that has nothing left to prove, and the silence between them stretches farther deeper until it feels like an ocean. Yet even now, astronomers notice something subtle in the widening gap. The fragments drift not in opposition, not in conflict, but in complement, their trajectories forming a soft, widening V-shape that looks almost like a gesture of release. It reminds you of two hands letting go of each other in slow motion. The smaller fragment leans outward in its bright arc. The larger fragment leans forward into its steady path. Both moving on, both carrying a piece of their shared beginning. There is a moment, weeks after the fracture, when the distance becomes so great that even the dust between them has fully dispersed. The bridge is gone. Only the quiet remains. This is the moment astronomers mark as full divergence, the point at which the two paths can no longer be described as part of a single event. But you listening to the drifting dark inside, you know that is not quite true. Because the universe does not erase connections simply because distance grows between them. The fragments reflect the same distant sun. They move through the same ancient vacuum. They come from the same star's ashes. And no matter how far apart they drift, their story will always begin in the same place. You breathe deeply, feeling the quiet weight of that truth. Goodbyes do not always come with sadness. Sometimes they come with a gentle understanding that something has changed shape and must now continue in a new direction. The fragments drift until the silence between them is no longer a separation, but space for both to become what they were meant to be. And you, lying here in the soft dark, feel something similar settle quietly within you. Because the universe is full of long goodbyes that are not endings, only transformations carried out in the language of drifting light. The night feels almost weightless around you now, as if the darkness has gathered itself into something soft enough to cradle every breath you take. It's a strange comfort, this quiet. A comfort that grows deeper each time you think of the fragments of 3IATLAS drifting above your world. Two tiny pieces of an ancient story carrying themselves outward into a place that no telescope can fully follow. They are far apart now, farther than the mind can easily picture, farther than any sound could travel, even if space allowed sound at all. And yet the distance between them does not feel like loss. It feels like release. The smaller fragment, that bright shimmering piece that once surprised every scientist who looked its way, still turns in sunlight with a clarity that refuses to fade, even as it drifts into regions where the sun is nothing but a pale coin of light. Its reflective face keeps catching photons, as though determined to hold on to every whisper of warmth the universe offers. You imagine it turning now, slow and quiet, its crystalline surface scattering sunlight into faint sparks that no eye will ever see, tiny echoes cast into an expanse that has forgotten the meaning of time. The larger fragment, steady muted, carrying the heavy calm of something ancient, continues forward with the patience of deep stone. Its warmth is fading. Its temperature is settling near the background chill of interstellar space. Its dust has fallen away. Its ionized breath has dimmed, but nothing in its movement feels like ending. It feels more like a long exhale, finally reaching rest. As the two fragments drift, their trajectories begin to take on the geometry of interstellar escape. There comes a point, a threshold, only mathematics tries to name, where the pull of the sun weakens enough that the fragments are no longer passing through the solar system, but leaving it, not dramatically, not suddenly, just gently, the way a thought leaves you after resting in your mind long enough to be understood. Scientists call this crossing the heliopause, the boundary where the solar wind dissolves into the cold pressure of interstellar particles. Crossing that invisible border is like walking from one type of silence into another. Inside the heliosphere, the sun still matters. Its light still warms. Its particles still push. Outside, the sun becomes a memory, a distant star, with no special claim on anything, drifting away from it. You breathe deeply, and the night around you feels like that boundary, a place where warmth fades, where shadows soften, where everything becomes quieter, but not colder. The smaller fragment reaches that border first. Its light dims as the sunlight thins to a fraction of the glow it once knew. But even in that dimness, the fragment's reflective ice keeps shining. Not brightly, not dramatically, just enough to say I'm still here. And there is something tender in that quiet resilience, the way a candle flame burns smaller, but never quite goes out. The larger fragment follows later, slipping across the boundary, with the stillness of something too old to be surprised anymore. Outside the heliosphere, both fragments enter a place so empty that the concept of distance loses meaning. A place where the nearest grain of dust may be kilometers away, where the nearest atom floats in solitude for centuries before meeting another. A place where nothing moves unless it has reason to. And yet the fragments continue drifting, carried by momentum that began long before the earth formed, long before the sun existed, long before any human voice ever spoke a word like wonder. You lie there, still breathing, still listening, and in the silence of your room, you feel something unexpected, a softness rising inside you, the kind that comes when you realize you are witnessing a thing that will never happen again in the same way. Because this moment, the moment when two pieces of an interstellar wanderer slip beyond the reach of your star, will never repeat. The light they carry now will only grow fainter. The signals captured by telescopes will thin until they look like noise. The brightness curves will flatten into silence. The motion will become guesswork. The chemistry will be a memory in old papers. And yet the fragments will continue far, far beyond the ability of any instrument to follow. Some scientists imagine they may one day enter another star's sphere, pulled in by some distant gravity into a new orbit, a new warmth, a new kind of light. Others believe they will drift forever, wandering through the galaxy, as relics carrying the ashes of a forgotten star. But the truth is simpler and softer. No one knows. And the unknown is not frightening here. It is gentle. It is wide. It opens like a quiet room at the end of a long hallway, a place where the universe finally rests. You breathe again, and the air feels slower, as if even your body is drifting outward with the fragments. There is something beautiful in not knowing where they will go. Something peaceful in trusting that the same physics that shaped them will carry them exactly where they must be. Maybe that is why you feel calm now, why the darkness around you feels like warm water instead of cold space. Because their journey does not require understanding, it only asks to be witnessed. A soft farewell to things that have wandered longer than your species has existed. A quiet blessing for objects that have known more silence than the universe can ever speak. And as your breathing slows and your body sinks deeper into stillness, you feel the truth of it rising like a tide inside you. Everything drifts, everything transforms, everything continues into the unknown, but nothing is ever lost. Not light, not motion, not memory, not the quiet ancient warmth carried in a fragment of ice drifting through the dark. You let that truth settle in you, soft, gentle, like a final whisper from a distant star, and somewhere far beyond anything you will ever see. The two fragments of 3IATLAS continue their long goodbye, each carrying a piece of a story that will drift with them into the endless quiet of the unknown.